let's take a look at solving trig equations. Now obviously we've seen basic ones like tan theta equals something. But usually the thing we've seen so far is it's a positive number. So what happens if it's negative? Well, now we have to take into account every possible angle that we can. Now, when you think about it, going around the circle, you can keep going round and round and round. There's actually an infinite number of answers, and that would be very hard to write down. So usually they'll say, okay, just give me the answers between these values. And a lot of the time it's between 0 and 360, one time round the circle. So okay, we know it's between 0 and 360. So the first thing we have to identify then is, well, which quadrants are we talking about? Tan's negative? We know tan's negative. We know tan's negative in the second and the fourth quadrants. Let's find the appropriate acute angle in each of those quadrants. It'll be the same, but what is that acute angle? So the acute angle will always be when it's positive. I give it a different pronumeral because it may or may not be in theta. In this case, it's not theta. That acute angle will be 67 degrees and 6 minutes. Well, now we can go and solve our problem. Draw myself a little diagram. We said the second and the fourth quadrant. So let's draw in those acute angles. So that gives me an idea. All right, I know that in the second quadrant, it's going to be 180 minus that one I just found. And in the fourth one, it's going to be 360 minus that one I just found. So let's work that out. And there's my two answers, 112.54, 292.54. So let's try another one. Cos theta equals a half. Once again, we're going between 0 and 360. That's one of our exact values, actually, isn't it? Locate the quadrants. This time, it's the first and the fourth quadrant. The acute angle is 60 degrees. So I know that in the first one, well, it's just normal. In the fourth one, 360 minus that. So I'll end up with 60 and 300 as my possible answers. Cosec. Unfortunately, we don't have a cosec button on a calculator. So the first thing we do is to turn it into a ratio that we do have on a calculator. And the reciprocal of cosec is sine. So it's the same as answering the question when sine theta equal to a quarter. Okay, sine, positive. We're in quadrants 1 and 2 this time. All right, find that acute angle. It's 14 degrees 29. So in the first quadrant, it's normal. Second quadrant, 180 minus the acute angle. So we end up with 14.29 and 165.31. So the procedure's the same each time. But now we get to equations like this where we might have to rearrange it. It's no different to a normal equation. Normal equation, we'd try and make x the subject. Well, in this case, before we can make x the subject, we have to make sine x the subject. So we treat it as if sine x is the pronumeral. So if I rearrange that one, I get sine x is negative a half. Okay, sine's negative. So I'm in the third and the fourth quadrant. And the acute angle for that one is 30 degrees. So we're looking for 180 plus the acute and 360 minus the acute. There's our two possible answers, 210, 330. Hang on, I've got two different trig ratios here. Whenever I see sine equaling cos, there's a really quick way to do it. Divide both sides by the cos. You'll end up with sine on cos, which is 10. So that's what I'm going to do here, but I'm also going to divide by the 5 as well, and I come up with tan theta's negative 2/5. So now that's the one I'm going to solve. We're in second and the fourth quadrants this time. So acute angle, 21.48. So it'll be 180 minus that, 360 minus that. There's our two possible answers. Cos 2 theta. Remember, we're trying to make theta the subject. But before I can make theta the subject, I've got to make the trig part the subject. So cos 2 theta. Well, hang on. It's 2 theta, not theta. Well, all right, I'll just look for more answers. If I'm looking for theta going between 0 and 360, let's say the angle I'm looking for now is, it's not theta, it's 2 theta that I'm looking for. And 2 theta, therefore, will go between 0 and 720. So I've got to go around the circle twice here to get the possible answers. First and fourth quadrant, the acute angle, 41.25, but that means 2 theta is that acute angle, or 360 minus. But of course that only gives me once around the circle. To get the other two values, just add 360 to both of those answers. So I've ended up with 4 answers for this one, but that's 2 theta. Remember, we're trying to find theta. Divide everything by 2, and we come up with 4 answers that does indeed lie between 0 and 360. Again, we've got 2 different trig results here. One of them squared. This is where our trig identities are going to come in handy, because I can change that sec squared to be 1 plus tan squared. And I end up creating a quadratic equation where the pronumeral is actually tan theta rather than, well, we'd normally see x or something like that. So what multiplies together to give negative 2 adds together to give 1. Yeah, that should work, shouldn't it? Negative 2 and 1. Is it negative 2 and 1? No, it's the other way around, isn't it? 2 and negative 1. So we get tan theta plus 2, tan theta minus 1, and we now have 2 answers we have to look for. We have to look for when is tan theta equal to negative 2, but also when is tan theta equal to 1. All right, let's start with the negative 2 first. That'll be the second quadrant and the fourth quadrant. Acute angle, 63 degrees 26. So we're going to go 180 minus that, or 360 minus that. There's our first two answers. Now let's look at tan theta equals 1. It's positive, so I'm in the first or the third quadrant. Acute angle, one of our exact values, 45 degrees. So first quadrant, that's normal. Third quadrant, 180 plus the acute. There's my next two. I don't leave my answer like that though. It shouldn't be for whoever's looking at your solution to pull everything together for the final answer. We should be providing that. So pull it all together. I like to put them in numerical order. I just think it looks neater. So 45, 116.34, 225 and 296.34 are our four possibilities for this particular one. Alrighty, 6H, but I've also put in one from the old Cambridge book there, 4G, and grabbed a handful of those questions that are interesting to look at.